Changing spark plugs is something we do routinely and don't give much thought to it. Maybe we should though, and that's the subject of today's edition of The Trainer. Today's edition of The Trainer is brought to you by Autolite. Autolite, igniting your passion. Learn more at www.autolite.com. The spark plug has a tough job to do, and it has to do it under extreme conditions. Exactly how does the spark plug manage to ignite the air-fuel mixture? The terminal or top end of the spark plug is connected to a high voltage supply source, the ignition coil. As current flows from the coil, a voltage potential builds between the center or positive electrode and the side or ground electrode. Now these two electrodes don't touch, do they? Does that mean it's an open circuit? Well, not quite. There is something between the two electrodes, air, or more precisely, the air-fuel mixture that was injected into the cylinder just a few micro moments before. Initially, this mixture acts as an insulator, but as the voltage potential grows, the gases begin to change. When the dielectric strength of the gases is reached, the gases ionize and become a conductor instead. No more open circuit. As the current flows across the now bridged gap, the temperature in the spark channel rises significantly and quickly. And the ionized gases expand just as quickly, almost like a small explosion. And if the spark event occurs outside of the combustion chamber, well, we've all heard the click of a spark plug. It's the same effect as thunder and lightning that you experience during a summer thunderstorm. The heat and pressure force the gases to react with one another, and ideally, near the end of the spark event, a small ball of fire or kernel has formed as the gases burn on their own. This tiny little fireball then expands to consume the surrounding gases, and combustion is realized. And the spark plug plays an important part in the combustion process. Even minor inefficiencies in the firing event can result in misfires that can be very hard to trace down. Now consider something as basic as the spark plug gap. If the gap is too small, the plug will still fire, but the spark may be too weak to ignite the air-fuel mixture. If the gap is too big, well, that places an excess demand on the coil, requiring more voltage to cross the gap. The plug will fire intermittently and maybe not at all. And the extra stress on the coil can actually lead to its premature failure. Even the process that we use to install the plugs can set the stage for premature failure or drivability issues. For example, a common mistake that we techs make is over-tightening the plugs during installation. When installing new plugs, a torque wrench should always be used. Over-tightening is common and can damage the plug, and that can lead to misfires. Using a torque wrench and tightening the plugs to the vehicle manufacturer's specifications ensures a tight seal, proper seating of the spark plug, and proper heat transfer between the combustion chamber through the plug to the cylinder head. Even how you select a replacement plug for your customer's vehicle is more important than you might think. For example, always use a plug that has the same fundamental technology, that is iridium for iridium or double platinum for double platinum, as the plug that was fitted at the factory. Or you can go with a direct OE replacement, like the Autolite Ultra. The Ultra is a true OE style plug that uses an iridium center electrode that is laser welded to the core. The 0.5 millimeter laser welded center wire provides a focused ignition, and the iridium-enhanced platinum alloy pad on the ground wire limits gap erosion for a 100,000-mile service life. If your customer's vehicle specifies an iridium plug, consider the Autolite Ultra. And no matter what brand you decide on for your customer's vehicle, make sure that you choose it based on an application-specific guide rather than a generic cross-reference chart. Relying on a cross-reference chart may just take you down the wrong path and have you selecting a plug that's just not going to do the job. And whether you're installing the same OE plug or a good aftermarket equivalent, you always want to make sure that you check the gap prior to installation. Check the gap as a go, no-go measurement using a round wire gauge rather than that wedge wheel you have on your keychain to avoid damaging the plug or the center electrode. And don't even think about using any kind of anti-seize on the plug threads. The majority of plugs made today use a special material when they construct the shell that makes this totally unnecessary. And if you do use some type of compound on the threads, you may find yourself over tightening the plugs unintentionally, even if you do use a torque wrench. This is due to the difference between wet and dry torque values. Over torquing can cause separation of the internal seat area where the ceramic core contacts the inside of the shell. This will impair the plug's ability to transfer heat, and it can lead to a damaging pre-ignition or detonation condition. Here's a few more tips to keep in mind when changing your customers' spark plugs. Most of the vehicles we service today use coil-on-plug ignition systems. On removal of the coil, inspect the boot for any visual sign of damage or arc through, and service is needed. Remove the new plug from its packaging and verify the plug gap is set to the vehicle manufacturer's specification. Use caution on plugs with precious metal tips to avoid damage, and if you do happen to drop one, throw that one away and get a replacement. Carefully start the plug in the head by hand. This avoids accidentally cross-threading the plug, a problem you don't want to have if you can avoid it. With the plug lightly seated, use a torque wrench to finish the install, tightening the plug to the OEM spec. Changing spark plugs is a routine job, sure, but today's high-technology engines are less forgiving of mistakes than they used to be, and it only takes a few extra minutes to do the job right. Thanks for watching.